So good morning all, we are going to see a topic on bubble trap. So bubble trap is one of an important safety device we are using in an extracorporeal circuit. So it has already mentioned here, it is a split-draw adult bubble trap. So this bubble trap have different parts. Can you name the parts? Inlet,
outlet,
bypass. Very good. It's an inlet, outlet and the bypass line. From where this inlet is coming it is coming from the oxygenator. Where this outlet is going?
To the patient side.
To the patient side. So it is going to the arterial line. So what is the main purpose of this bubble trap?
to remove the bubbles.
Yes, it is used to remove the bubbles from the extracorporeal circuit. Not only bubbles, it removes the fat embolism and further debris from the circuit also. So it is removing this through a vein port. The air is removing through a vein port. So you can see a white color filter which is present on inside, which will remove the debris. So the main purpose of this is to use as a final defense mechanism to remove all the air before entering into a patient. So this circuit will be assembled in the extracorporeal circuit where the inlet is connected from an oxygenator. So how to prime the circuit is, before priming you want to do an assembly procedure. So it can be in pre-assembled circuit also from the customer. So some institution will start assembling on its own, and this circuit will have this inlet, bridge line and the outlet. From the inlet you will be clamping the inlet and the outlet line. So first step is to clamp the inlet and outlet line. So whatever the priming solution you are adding, that will be directly goes to the bypass line. From bypass line it will be going to the arterial line. This arterial line will be connected as a loop to the venous line for priming purpose. So it is the first step. So automatically this bypass line will be free of air. It is filled with the primary solution and it is free of air. The next step I have to do is, you want to, it is already clamped in the inlet and the outlet. Now what I am doing is, I am removing a clamp from the outlet line and placing the clamp on the arterial line. So that from the bypass line,
the fluid will move to
the fluid will move to the bubble trap, and this flow is called as retrograde flow. Automatically through retrograde flow, the fluid will be reaching into a bubble trap. So can you hold this? Okay. So now I am going to add a vein port. So the vein port is always to be a three-way stop lock, so that it can be placed in the heart-lung machine, and this port will be connected with a slow pressure port. That is, you are connecting this with a venous reservoir. The purpose is to remove the air. So this port is called as purge port with the three-way stop lock. Now I have connected here, and through the retrograde flow, the flow has been coming to the bubble trap. I am opening the vein port here. So the air can be automatically removed through the venous reservoir. And which line is not primed till now? Inlet line. So next I will be removing the clamp from the inlet line. I will be placing the clamp in the bypass line. That means what? This line is already filled with fluid. So I am placing the clamp in the bypass line. So automatically the flow will start reaching through this inlet line. So this inlet line will also get primed. So while doing this, what is the flow rate I can kept on the pump is 100 to 200 ml per minute. So it is a minimal flow rate is required to prime this entire circuit before it goes. Okay. Any doubts here? Okay.
So same like this time, when the fluid is coming here, the air from here will move.
Yeah. Fluid is coming here, the air will be flowing from here. So automatically this step is required only a minimal flow. Why? Because if you give a high level of flow, automatically there will be a damage in the inlet port. So you are giving a very minimal flow. Some of the circuit nowadays is coming as an integrated. Integrated means it is already present inside an oxygenator and it is not coming separately. So what is the main advantages of connecting this?
It removes the microenvironment.
Okay.
Before enter air in the pressure.
Okay. So the priming of this circuit is also very much important. Why? Because if you trap any air in the inlet or outlet, it will directly enter into the arterial line of a patient. And this is a disposable thing, but it is already an ETO sterilized circuit. So it comes with an ETO sterilization itself already, but we cannot able to reuse this circuit. Why? Because you have a filters. The filters will have one micro particles or an fat embolism or an blood debris. So we cannot able to use this as reusable things. Okay. So what is the purpose of purge is to remove air. So this purge has to be running on the bypass. If your pump gets stops, okay, if your pump gets stops or any case, or you are stopping a pump, you have to clamp this purge line, or you have to stop this purge line. What is the reason for it? The reason will be the air from the circuit can be coming inside this already, or else it will do one retrograde flow. The flow from any circuit can enter here. So when you off the pump, automatically you want to off the purge port. You want to check this, turn off your stop clamp, and you want to off the purge port. But while you are going on bypass, it is mandatory that you want to check your vent line is open and the purge is working. So the reason for connecting the purge with the low pressure circuit on the reservoir is to avoid the backflow of blood. So the backflow of blood is the main reason. So we are avoiding this through a purge port.
So when the pump gets turned off due to some reasons, we have to off
we have to off the things. And also you want to tilt the bubble trap to remove the air. So many circuits will be tapping the line. You cannot directly tap on the bubble trap. You can tap the inlet and outlet and the bypass line, so that you will remove the air directly from the circuit. And finally, you want to place the bubble trap as such on the holder. It has a separate holder, and we will be placing that in a holder.